Next is problem number 7. Now, problem number 7 we did in the warm-up today in class. This is the sunspot problem. For several hundred years, astronomers have kept track of the number of solar flares or sunspots that occur on the surface of the sun. The number of sunspots in a given year varies periodically from a minimum of about 10 per year to a maximum of about 110 per year. Between 1750 and 1948, there were exactly 18 complete cycles. We know our minimum's 10, our max is 110, so let's graph that. Now, once again, these are all positive numbers, so we're going to be in the first quadrant. I don't need any negatives here, so this will be my x-axis. And this is my y-axis. So this is y, this is x. Now we're told that the minimum is 10 and the max is 110. So we're going to draw broken lines here, and our graph is going to be trapped between these two, the max and the min here. Okay, now let's find the amplitude. Amplitude is going to be 110 minus 10 divided by 2 of 50. Amplitude is 50. A is the amplitude, so that's 50. The vertical shift is going to be 110 plus 10 divided by 2, so that'll be 60. Vertical shift is 60. That's going to be our D. So let's call this 60. That's D. Now this will be our x prime too. This is our new x-axis. So we're going to measure things from this. X prime. Okay, now let's find out what the period is for sunspots. Now we know that between 1948 in 1750, there were 18 complete cycles. So if we can find out how long one of these cycles lasts, that's going to be our period. So what we're going to do is take 1948 minus 1750. We know there were 18 within that period, so each of them lasted 11 years. So our period is 11. And B is going to be 2 pi divided by 11. So we've got A, we've got B, we've got D. Let's see if we can find C. Now we're told that we had a complete cycle in 1948. So if we start at 1948, let's call this 1948. We're starting a new cycle, so we're going to be at a low point here. In 10 years, or 11 years rather, which is the period, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now this will be 1959. We're starting a new cycle, so we're here. Now halfway between 1959 and 1948, we'll be at the peak up here, at the maximum. So 11 divided by 2 is 5.5, so this is 48. 1, 2, 3, 4, 5. So here we're here. Now since we're starting our time in 1948, we're moving the y-axis from 0 over to 1948. That's going to be our y prime. It's also our phase shift. So this is y prime. So the phase shift is 1948, and that's going to be C, 1948. So one cycle of the graph is going to look like this. And I'll fill this in since my highlighter isn't very visible. Okay. Now let's see what that looks like. This is our new origin. If it were a sine function, it would start here. If it was positive cosine, it would start up here. But it's negative cosine since it's down here, so we're going to use this one. Let's pick some key points. In 1948, our value should be 10. In, what is this, 1959, it should also be 10. So the equation, since it's negative, is y equals negative 50 cosine 2 pi over 11 times x minus 1948 plus d. Now let's set our window. For the minimum x value, let's start with 1948. And we're asked what the sunspot activity will be in 2020. So we're going to need to go up past 2020. So let's go up to 2025. And our y value has a minimum of 10, so let's go with 5. And a maximum value of 110, so we'll do 115. Let's put our equation in. Negative 50 cosine of 2 pi divided by 11 x minus 1948 plus 60. So that's our equation. And let's graph it and see what we get. And that's kind of rough, but it does seem to agree with this. Now let's check our key points. So second trace, and let's put in 1948, and we expect to get 10 out, which we did. And let's put in 1959, and we get 10 out. Now we're asked what's it going to be in 2020. So let's put in 2020, and we see it's going to be 107.97, so 108. Okay, let's stop there. Now that was problem number 7.